We're back again for Advent of Code 2022 day 5. I've gone ahead and increased the delay on the solve part of the stream to 2 minutes. I'm going to constantly play around with it, I guess. I remembered that Eric did ask on the About page to don't stream if you're likely to hit the leaderboard. I don't know how likely I am to actually be hitting the leaderboard this year, but just out of respect for that, trying to have a bit of a higher delay. I think I'd be more opposed to it, but since I figured out a way to bring the stream magically back into real time afterwards, it's not as big a deal. It'll just be a bit weird that it's happening in the past when you're actually watching the first part of the stream, but it still makes a cohesive video, so I'm pretty happy with that. Yep. Anyways, still the same stuff. I don't think today's problem will be exceptionally tricky or anything. Just trying to not make dumb mistakes and understand how the utility functions that I wrote work and whatnot. It'll be interesting to see when the AI solutions start to fall off, though. That's kind of what I'm most interested in personally. But yeah, I think I have OBS open because I have to click go live at the end of the initial stream delay, which is kind of annoying. I don't know if there's a way to make it so it'll just automatically go live. I haven't quite figured it out yet. But let's see what happens. So I think this thing turns like that, and then I have to click it. And that starts the broadcast. Yep. Let's see. Yeah, I don't quite remember when the problems start getting more non-trivial, I guess. Probably definitely past day 10. But I do remember they've, in past years, they've had some kind of tricky stuff thrown in from like days 5 to 10. I'm mostly curious to see if the virtual machine stuff crops up this year. It was a pretty common, I guess, theme of the competition to be building your own virtual machine, basically, that comes back. It's like a recurring thing you need to use in future problems. Those problems were always fun. I think it'll be a fun meta thing to see if the AI solutions can solve problems related to building a basically an emulator. But yes, we will focus up. I think when I take this too seriously, then I start to make mistakes. So just gonna try to read properly. Okay, this output already is not very nice. Okay, AI better not be able to solve this problem is all I have to say. What's the easiest way to parse this? It's like one, I want 2 and then every 4. So it's on the bottom. So it's like, I just need to make sure one. Do they all move at once? Yeah. So it's one at a time. Okay. So it's from this. And then that tuple. Oh, wait. Ooh, wait, how do I, okay, undo. Okay, that's kind of what I expected. It's Wow. Was that a double 39? 39 here. 39 here. Well, pretty consistent. Okay. Let me try to readjust my stream. So I do this. Okay, I think I initially messed this up, but I should be back. Ah, yes, okay. Cool. I just want to confirm that the leaderboard closed up. Yep. And we're back. Wow. Okay, we're back live in real time. So, yeah, actually leaderboarded today, so that's always nice. This was a rather intimidating question, if only for the input parsing part of it. So I'm gonna brush this aside for now. I did a little bit of magic to parse the input. I'm gonna come back to it. Ignore this magic. And I guess it probably makes sense to just go through the actual problem first. So let's remove all of this stuff. I'll go back and figure out a way to go through the input parsing afterwards, but I think just to start, let's go through the actual problem. So the problem is called supply stacks. Essentially, there are many stacks of these crates. Let's take a look at what the full input even looks like for this question. So there's like 9 separate stacks of crates, all with different things in them. And so you're given the initial state of what the crates look like, and then a list of moves. So basically, in this example here, it would say move 1 crate from the second column to the first column. So the D would be picked up by the crane and then dropped to the first, resulting in this. And then it says move 3 from the first column to the third column. The important thing to note here is that it does it incrementally. So it doesn't just lift the whole stack. It'll put the D above the P. That's why it's here. Then it'll take the N, put it on the D, and then the Z, and put it on the N. So if you're familiar with data structures, this is very similar. These are basically stacks, right? This is how a stack operates. It's kind of hinted to you by the problem name. And so stacks are first in, last out, right? So yeah. So the thing that goes in on the top is the first thing out when you're taking things off. So that's the important thing to keep in mind when doing an implementation of this. So I'm going to say ignore all of the input parsing magic, and let's just pretend that we have these 2 magic variables called stacks. Let's print out what stacks is, and then print out what moves is. And I promise I'll go back and do the input parsing later. So if we run this, let me clear my terminal. Oh, that's the wrong thing. Sorry, fumbling. So the way I did my input parsing is in stacks, we have a list of all of the stacks with the characters in them. So for example, this ZN here represents the first stack here with a Z at the bottom and N on top. And the second thing in the list is the M, C, D, and the third thing is the P. Then we did some parsing to understand these move lists. So these are just all tuples. So it's saying for the first move, we want to move 1 thing from column 2 to column 1. Okay, so that's the contents of those lists. So assuming we have these variables, how do we want to code this up? And so we're going to want to say for move, it moves, right? We want to say, let's give some better names to this than when I was actually solving it. So we'll call the first thing the amount, the second thing, I guess, from, and then the next thing to. So a nice thing about Python is that if you were going to, remember, move is a bunch of tuples, right? And I want to assign names to them. So one way you could do this is just like the first element is the amount, the second element, is this, so on and so forth. But if you know the length of the tuple, you can actually assign them variable names like this. And you can actually do that inline in your for statement as well. So you could do something like this for the amount, from, and to, and moves. We can just like recreate this string, like move amount from to, right? Oh, and because I was highlighting in my terminal, I was doing bad copy pasted. Too many values to unpack, expected 3. Oh, this variable is capital moves, right? Okay, so we've recovered these. Now we actually have to do things on them. So we want to operate on our magic stacks variable, right? So what do we want to do? We basically have to do these operations. We can just do it exactly how you would do it conceptually. So for the number of times in what amount is, so in range amount, the underscore is just a typical way to basically say, I don't care what this variable name is in Python. Oh, something else to note. These numbers will be 1 indexed, as in they're starting from 1, because the column names go, or numbers go 1, 2, 3. So what I did was just at the very start, I subtracted 1 from each of from and to. That made it so they'd be 0 indexed, so it'd be easier to write the the code afterwards. So at this point, what do we want to do? Well, the algorithm tells us what we want to do, right? We're going to pop something off of, or take something off the top of the from stack. So I guess we can call it, are they crates? Yeah, crate equals, so in our stacks, it's what we're taking from, and we're going to pop the top element off of it, and we're going to push it onto the to stack. And the way we want to do that for a Python list is just append. We'll append the crate. And if you do that, then if we print out, I guess, yeah, we can just print out stacks. And if we run this, oops, this should be from, not format. Okay, we run this. I don't know why I was typing format. I've been writing too much Go code and importing the format library. Great, so the end state of our stacks after the sample looks like this. And that matches what we have here. We have C by itself in the first column, and M by itself, and then P, D, and Z. So now the question is, the elves want to know which crate will end up on the top of each stack. So a nice way to do that in Python, in other languages, right, you might have to compute what the, so if I said if I only cared about the first stack, right, and I wanted to know what the last element of that is, you might have to do something like, stack, and then like length of stack minus 1. A nice thing about Python is you can use negative indices to do that for you. So saying -1 will just give you the last element of the array, no matter how long it is. -2 will tell you the second last element, no matter how long it is. So we can use that to advantage. We can say, so the answer is going to be this, and then for stack in our stacks, we can just say, basically add the last crate in that stack, which is stack -1. And then we're going to print the answer. So if we run it here, we get CMZ, which was the sample. And if we run it on my full problem input, we get this. While I was solving, I determined it'd be faster for me to just type this manually. I guess a shortcut you could have done is the answer is equal to, you can use like join to join together the characters, and then do a generator comprehension. So like the last element in every stack for S in stacks, So here's a compact one-line way to do the same thing that was there before. If we run this, same sort of thing. Great. So that was part one. For part two, the hunch. So I guess a technique for advent of code as well. Usually the part two builds upon the part one, right? And so what's the logical thing to do from this problem without changing the input at all? Well, it'd be to change the behavior of how the crates are moving around. And indeed, that's the case. We get a crate mover 9001. Oh, there's no, I was expecting a it's over 9,000 reference. But it can pick up multiple crates at once. So instead, moving a single crate from here to here is the exact same. But for the next move operation, remember it says move 3 crates from 1 to 3. And in this example, we move like D over, and then N, and then Z. So what happened effectively was it flipped the order. We have D and Z going top to bottom, and then D and Z going bottom to top. In this example here, now we have the D and Z staying in the same order because the super crane picked up the entire stack of crates and moved them all over here. So I decided the easiest way to do this was to just say, we want to figure out what this big column that we're moving is. So I can call it the column of crates, I guess. And it's always going to start at the top of the stack. So in this example, for example, we want to take the top one, the next one, and the one after that, 3, right? And so what we can do in Python is like slice a string, right? Or slice an array. Stacks. So we're taking it from the from stack, and you can do a slice saying this is where the subarray should start, and this is where the subarray should end. We can use negative indices to our advantage here again by saying I want to take the last n elements of the array, where n is the amount because it's the number of things that we want to take. And then we don't need to do this for loop anymore, right? Because we're not doing like a pop, pop, pop. We're just moving the whole thing over. So we get our new column of crates. We'll just call it crates to move. And then we can just plop them onto the to stack. And the way to do that when you have a list of things to add to an array rather than a single element is extend. So like that. And then the same code will work to print it off, right? So I'm just going to copy this again and run this. Oh, that is not the right answer. Oh, I didn't pop them off. So we do have to remove the elements from the array as well. This is just like grabbing the subarray. We do want to move stuff off. I'm trying to think, does Python's pop actually allow you to pop multiple things? What would be the best way to do this if I don't want to iterate over it? Oh, it looks, remove probably isn't the right thing. And pop removes something from an index. I don't remember what I did when I was actually solving the problem, but I mean, one way to do it is just doing that same loop for in range amount. It's not the most efficient thing to do, but we can just pop something off of it and discard it. We don't need what that thing is anymore. We just want to get it off of this stack, right? There might be a better way to do this. There almost certainly is, but I'm too lazy to look stuff up right now. Oh yeah, we get MCD here, and then if we run it against the real input, we get the answer for part 2. I guess something interesting to note is we can actually make part 1 and part 2 very similar to one another if we do it this way. we just always, so this is going to be the crate that we're popping from the stack, like this, and we're going to append the crate, and then we're going to extend crates to move here. This is like another way to make the code a bit more similar between parts 1 and part 2. If part 1 need to flip this. So remember that the difference in behavior between part 1 and part 2 is in here, this D and Z stayed in the same order, versus in part 1, right, we had D and Z here, and then they flipped. So if it's part 1, you could actually just do it so that you reverse this array, so that we extend this column with the D and Z, but we flip the elements before we stick it on top. That would work. Again, you know, this is not necessarily the most efficient way to solve the code from like a strictly competitive programming perspective, but this is very few instructions for a computer to execute, and these are not big stacks of crates, so pretty much anything goes. So that's the logical part of the problem. Now I guess we get to how to actually parse the input, and I guess I'll try to explain what I actually did. So this is a magical thing that grabs the problem input, fine. And then pairs basically gives me things that are separated by an empty line. So the board is the first grouping of things, I guess, and then the list of moves is the second. Great. So the list of moves is not the difficult part. You could write a regex to pull out the numbers right from here, or there's this convenient parse enums thing that basically a lot of people who are doing advent of code have a little helper to do this. It basically goes through these things and asks, hey, give me all the things that look like numbers. And so that's all I'm doing here to get the moves. The part that I immediately was squirming at was, how do we parse this? Because it's really easy to parse things when they're all on the same row, right? Because we can just operate by lines. But with this, I guess Eric was nice enough to include spaces for empty lines, like trailing white space, so that you could do something like that. But yeah, this I had to think a bit about how I wanted to parse this, and the way I decided to do it is a little interesting, I guess, to say the least. Let's do something like this. So if we just look at the structure of what board looks like, off the bat, we do something like this. It's like, these are the independent lines, right? And so, what do we really care about in this? Well, we can throw away the 1, 2, 3. That's kind of useless. What we really would rather do, though, is, at least the way I was thinking about it, is look at a vertical view of this rather than a horizontal view. And so I have a helper function rotated to rotate 2D matrices, and a list of strings is basically a 2D matrix, right? It's a list of lists of characters. So if we rotate this around, this is a little hard to interpret. So I'm gonna do this, and for line in R, print, I'm gonna make it just into a string again. We basically get this back. The important part is that we see the Zn here for Zn. We see the MCD here for MCD. And we see the P here for this. And the reason why there's all these garbage lines in the middle is because they represent, you know, these columns. Essentially, the first line here is what is in the first column, right? It's this bracket and this bracket. Then what's in the second column? It's, I guess we're going upwards. It's 1Zn, right? And what's in the third column? empty space, close bracket, close bracket. So the useful information starts on the second line, and we skip 4 because there's 4, or we skip 3 because there's like 3 things of filler in between, and then we get a useful line. Then we have to skip by 3, and then there's another useful line in the middle. So that's what I was doing here. I rotated the input to turn it on its side and kind of get the columns back. Then I said start at the second row, and then skip 3, so pick every 4th, and then from there I just parsed out the crates. If I'm trying to think if there's like a pretty way to do this, well, maybe without rotating the matrices. There could be. I just thought it would be pretty tricky because of the fact that there could be like these empty spaces in between with the crates, and I just didn't want to deal with that. So by just rotating them first and reading them off like they were already lists, I thought it was the easiest way to kind of not have out of bounds exceptions on this problem. So that's basically what I was doing here. I think if I were to implement this without rotating the matrix, it would be something like start at the bottom and work your way up based on how many columns you have. You know what? Let's do this as a coding exercise. We'll go through it. So I'm going to say for a line in board, but I want to iterate over it in the opposite direction because I want to start at the bottom and work my way up. So first I'm going to create empty lists for each of the stacks. And so how are we going to do this? We first have to figure out how many columns are in the stack. So how many columns there are independently. So let's do that first. So we'll say number of stacks is going to be so I guess bottom is going to be, I want to fetch this row, right? It's going to be the last thing in board. And I'm going to say number of stacks is going to be the maximum of, we have to intify these strings, int x for x in bottom dot split. I wonder if that works. Honestly, I would just use my parse numbers utility to do this, but this probably also works too. So let's try that out. 3. There's 3 columns here, and if I run it on the real input, we get 9 columns. Great. So this allows us to define our stacks, which is going to be an empty list for based on how many total stacks there are. So now we have something to push our elements into. So now the next stage is to actually iterate through the board, right? From the bottom up, we're going to iterate over these lines. So it looks like this. So for each line, I'm going to, I guess, look at the second element. So we can do a similar thing where we jump 4 and see if there's anything there. And if there is, we push into that particular stack. So for I, create in enumerate, I guess, line, and we start at the first thing in the string and skip by 3. We're going to say stacks, the ith stack, we need to push the crate character onto it. Right. But luckily, this didn't make a difference here. Oh wait, no, it did, I think. we also don't want to push something if there's an empty string here, right? That shouldn't count. So if crate is not equal to the empty string, we'll push it. Or actually, even better, if crate dot is an uppercase character, I think is the method name, we'll do that. Okay, so that lets us parse the input correctly. Now that I look at it, this isn't actually so bad. It just wasn't what came to mind when I was frantically when I looked at this and I was like, oh geez, how am I gonna parse this? But yep. So I guess just to complete it, how would you get this out without like something magical? If you just read all the lines in, you could do something where you are appending everything to one list until you see the double new line, or you can read in the whole input, split on new line to get this part, and then you just iterate through these lines. Okay, I think that about finishes it up for today, but out of curiosity, I'm gonna click on this and look at this a little more closely. Yes, AI was not able to solve this question. The people who I know were solving via AI do not seem to be on this list. So the AI was fooled by this ASCII art. Maybe that's the future of adventive code, doing ASCII art pictures to trick the AI. Anyways, happy about today, got back on the leaderboard, so thank you for watching.